Hi, I am Kea Shalu. I have spent the last 20 plus years as a software engineer and teacher. I've designed and teach this framework at UC Berkeley, Info 153B and 253B Backend Web Architecture. This is Course 3, Real-Time and Communication Systems. If you completed Course 2, you know how to optimize for reads, blog architectures, video pipelines, search indexes. You know why content systems are designed the way they are. Real-time systems are a different problem. They do not optimize for throughput, they optimize for latency. The time between something happening and the user knowing it. That constraint changes every building block decision you make. 3 minutes from inside Course 3, let me show you what's in it. Here's the problem. An email with 1 second delay feels completely normal. A Slack message with a 1 second delay feels broken. A video call with 500 milliseconds of lag is unusable. A Google Docs cursor that trails your keystrokes by 200 milliseconds is maddening. The difference is not the technology, it's the expectation. Real-time communication creates an expectation of instant, and designing for instant is a completely different discipline than designing for eventuality. Most engineers can build a system that works. Send a message, it gets there, correct. Very few engineers can build a system that feels instant. The difference is understanding which patterns create low latency and which ones silently destroy it. Whether you are building messaging, collaboration tools, AI chatbots, or video conferencing, the same patterns keep appearing. Course 3 teaches you those patterns. Same vocabulary, 7 building blocks, 3 external entities. Course 3 does not reteach these. What Course 3 does is show you how these blocks behave under a latency constraint. The queue that buffers background work in a content system becomes a message delivery channel in a real-time system. The key value store that holds cached pages now holds present state and typing indicators. The external service that sends a notification email now delivers a push message in sub 100 milliseconds. The blocks are the same. The latency requirement reshapes every decision about how you use them. Course 3 has 9 lessons. Each one applies to the building block vocabulary to a different real-time communication archetype. The prerequisite is Course 1. You need the vocabulary. If you also completed Course 2, you already see how blocks combine inside real systems, which will make Course 3 faster. If you only completed Course 1, that's enough. Here is what Course 3 looks like. 9 lessons across 5 case study archetypes: social media activity feeds, collaborative document editing, messaging apps, AI chatbots, and video conferencing. Each one a different latency profile. Each one a different combination of blocks. 2 discovery labs where you run experiments rather than read about them. 1 3-part design challenge where you design a full team collaboration platform. 1 AI-graded assessment. Here are the 5 case studies in Course 3 social media platform. Q plus worker for activity feeds. When a post with 1 million followers go live, the fan out to all those feeds cannot happen synchronously. You'll learn how it actually works. The queue absorbs the event, workers distribute it, and the poster gets an immediate response while the delivery happens in the background. Collaborative document editing. How Google Docs handles 2 people editing the same sentence at the same time without corrupting either edit. Operational transform. Conflict resolution. You'll never look at a collaborative document the same way again. Messaging apps. How WhatsApp and Slack handle delivery guarantees, message ordering, presence indicators, and multimedia. The difference between sent and delivered and read actually requires at the architecture level. AI chatbots, vector database plus external service for content management. How a chatbot remembers what you said 3 turns ago without reading the entire conversation history into memory on every response. Video conferencing, hard real time, the strictest latency requirements in software. How Zoom and Teams handle audio and video encoding, quality adaptation for variable networks, and staying synchronized across thousands of concurrent calls. 5 patterns, 5 architectures, all built from the same 7 blocks. After Course 3, 4 things change. You understand why Slack messages feel instant and email does not. You can describe the exact pattern that makes the difference. Queue plus service, message delivery through a persistent connection rather than polling. Present state in a key value store. You see it. You'll understand how Google Docs handles 2 people editing the same line without corrupting either edit. Operational transform, conflict resolution. You understand what the architecture requires to make that work, and you recognize the same pattern in any collaborative tool you encounter. You understand why AI chatbot uses a vector database for context and not a relational database. You'll know what semantic similarity search is doing. You can explain why chatbot retrieves the most relevant parts of the conversation history rather than reading the whole thing. And when a real-time feature feels laggy, you'll know where to look. Is the service blocking on something synchronous that should be async? Is the queue backing up? Is the fan-out worker too slow? You ask those questions automatically because you know the patterns. You do not build real-time systems by making things faster. You build them by choosing which blocks create the latency the product can live with. That is what Course 3 gives you.